Hi everyone, it's Mrs. Griffin with the Unit 5 Lesson 9 video. We're going to be doing dilations, scale factors, and centers of dilation on the coordinate plane, the XY axes. So you're going to try this opening exercise on your own, and we are going to go down to the notes. So first off, dilation centered at the origin, where they'll often use a capital O, are going to take your points x and y and turn them to r times x and r times y. R is the scale factor. So basically, we're just multiplying the coordinates by the scale factor. And again, this only works when centered at the origin for your dilation. So on number 1, here are the coordinates of A, B, and C. If we're dilating from the origin by 2, that means that we are going to take every single one of these coordinate points, x's and y's, and we're going to multiply each one by 2. So 3 times 2 is 6, 7 times 2 is 14, and we will do all of them all by 2. And then what will happen is we will graph these 3 points. And then when we connect them, we'll get the dilated triangle, which is centered at the origin. If you notice, the distance between the origin and each point has doubled, just like it was doing with our constructions. These distances all are multiplied by 2. So if you were to count from the origin to C, for example, you'd go up 4 and right 8. Going up 4 and right 8 again would get you to C prime, and that's the scale factor of 2. So the multiplication is just a shortcut. Alright, if we do the rest of this page here, if we're dilating by 2 for these triangles, again, all we're doing, because we're dilating through the origin, is multiplying each of the coordinates x and y by 2, and these are the answers that we are getting. And then the same thing for this. Now we're multiplying these all by 2/3. Remember, multiplying a number, for example, -3 times 2/3, you're multiplying the top, which would be -6, and then dividing by 3. And so -6 divided by 3 is -2. Take 6 times 2 is 12, divide by 3, you'll get 4. And you're going to do the same thing for L and I. 0 times anything is 0. 3 times 2 is 6, divided by 3 is 2. And then for I, 6 times 2 is 12, divided by 3 is 4, and 0 times anything is 0. Now going back up, if we're dilating through any other point at all, we're going to do this on the graph. So we're going to count from the center of dilation, which is that other point, to each point in the pre-image. Then we're going to multiply the count, how far it is, by the scale factor. And then we're going to start back at the center of dilation and recount the new count. So if we go on to the next page, for example, number 3, we're dilating through the center of dilation will be 0, 3, which is this point, and we're going to multiply every count by 1/4. So if you look at the distance or the count to get from this center of dilation, I'll call it P, to point A. How you get from P to point A is that you go up 2, 3, 4. You go up 4. We're going to multiply that by 1/4 and only go up 1. So from P, our new point will be here, and this will be your A prime. Then we're going to do the same thing from P to B. How do you get from P to B? You go to the right 4 units. We're going to multiply that by the scale factor and now only go right 1 unit. And so when you go back from center P, right 1 unit, this will be your B prime. And then the same thing to get from P to C. We have to go right 2, 3, 4 and down 2, 3, 4. So we're doing both, down 4 and right 4, and multiplying each of those counts by the 1/4, and then ending up only going down 1 and right 1. So we're going back to the center of dilation to begin counting, and we're going right 1 and down 1, which will put our C prime here. And then you can make your new triangle. All right. If the scale factor is bigger than 1 and it makes the number larger, like here where we're going to do a center of dilation of 0, -1, but our scale factor is 2, you can do almost a shortcut. You can go from that point to A is only up 1, and we're going to double it because the scale factor is 2, and go up another 1. And that'll be A prime. To get from this center of dilation, I'll call it P, to B, you have to go up right. If you go up right again, you'll get your B prime because you've gone twice. Down right for C, 1 unit each. Down right again will get you C prime, and then you can just connect and make your new triangle. All right. Okay, now if your center of dilation is P and we're dilating by 2, we can do the same thing I was just saying, where we could just count again. We can just count it twice. So to get from P to J, 1, 2, 3, 4, 5, 6, I'm going up 6 units. So I need to go up a total of 12, which would be another 6. 1, 2, 3, 4, 5, 6. And that'll be your J prime. Same thing for K. Go up 2, 3, and right 1. If you go up 2, 3, and right 1 again, you'll have K prime. And for L, if you go up 2, 3, 1, 2, 3, 4, 5, up 2, 3, 1, 2, 3, 4, 5, and you'll have your L prime. And then we have our triangle. Now sometimes, a lot of times, it will say state the coordinates. Make sure you do if they ask you to. If we look at number 6, we're dilating from P, which is on the picture. Since P is a point on the picture, it's going to remain fixed. It's not going to move. Everything is going to move towards it or further away from it. And in this case, because our scale factor is 1/3, it's going to go towards it. So what I'm actually doing is I'm going to do the count from P to T. This is not something you have to write, but it does help most of us. So if we're going from P to T, we're going up 1, 2, 3, 4, 5, 6, 7, 8, 9, and left 3. And each one of those is going to get multiplied by the 1/3. And so we will only go up 3 and left 1. And that'll be your T prime. Do the same thing to get from P to D. So to get from P to D, you have to go up 9 and right 9. And we're multiplying each one of those by 1/3. So we're going up 3 and right 3. And remember to start that count back at point P, the center of dilation. Up 2, 3, right 2, 3. And that will be D prime. And then get from P to Z, it's 1, 2, 3, 4, 5, 6 units to the right. So if we multiply that by 1/3, we're only going to go right 2 units, and this will be Z prime. And we'll have our new trapezoid. Notice that we have a composition, meaning it has the little circles, which mean after, and remember how we always do those right to left. This is a combination of rigid motions, like translation and rotation, along with our dilation. This is what we call a similarity transformation. So we're going to do all 3 parts to it. So for starters, we're going to rotate this 180 degrees around O, which is the origin. If you were to do that, then A would move to -3, -1. B would move to -8, -2, and C would move to -5, -10, here. The next thing we would do would be the translation of 3, 4. Remember that that's going to mean you're going right 3 and up 4, or you can simply add 3 to all your x values and add 4 to all your y values. So adding 3 would give you 0, -5, and -2, and adding 4 would give you 3, 2, and -6. Or you can shift, like I said, right 2, 3, and up 2, 3, 4 for each one of your points. And you would have your double prime triangle. The final thing that we are going to do is the dilation of 1/2. So what we can do, because it's centered at the origin, is just multiply each part of the coordinates by 1/2 to get each one. So 0 times 1/2 is 0, 3 times 1/2 is 1.5, etc., multiplying them all by 1/2. And you would get this triangle. Okay, as we go on to number 8, we have the triangle already graphed for us. Notice that in this one, part A, we're graphing and stating the coordinates of the image of triangle RST. And then for part B, we're also doing the image of triangle RST. And for part C, the same thing. That means that for each one of these, we're going back to the original triangle for our counts. So keep that in mind. Also, when we have a composition of 2 dilations, we can actually combine them just like we could with translations. We can multiply the scale factors as long as the centers are the same. So 2/3 times 3, 2 times 3 is 6, divided by 3 is 2. And so we're really dilating this around the origin by 2. So you can do that by multiplying your coordinates by 2. because we are dilating through the origin, or you can do the counting from the origin every time like we did when we were using other centers. So for example, to get from the origin to S, you have to go up one, right one. You could just double that, do it again. Same thing for here, for T, and also for R. And you would get your new triangle, R prime, S prime, T prime. Notice all the segments are parallel to the ones they started with. Okay, now for part B, what we are doing is a translation of 8, -4, and again doing that from the original triangle. So remember, if it's 8, -4, you're going right first and then down 4, or you can add 8 and subtract 4 for the points. So for part B, if you were just adding 8 and then subtracting 4, you would get 10, -7. For S, adding 8 and subtracting 4, and for T, adding 8 and subtracting 4. Or like I said, you could go right 8, 1, 2, 3, 4, 7, 8, and then down 4, but from the original. And you would get R prime, S prime, double prime, and T double prime that way. Notice this one was a rigid motion, that's why it was the same size as the other one versus the purple one, A. And then finally for C, we are going to do 2 different reflections working right to left. First, we're going to reflect over the line x equals 4. So I'm going to graph that line in green here. Now remember, we're starting with RST, the original. So to reflect it over the x equals 4, I'm going to start with R. We're going to go 1, 2 units to get to R, 1, 2 units to get past it. And we would be here, and then we're going to reflect that over the x-axis. So we're going to move to this point here. And this will be our R triple prime. Same thing with S. We're going to go from the original S, 1, 2, 3 units to get to x equals 4, 1, 2, 3 units past, and then we're going to go reflect it over the x-axis to get here. And then finally the same thing with T. We'll start at the original T, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and then reflect over the x-axis to get to this point here. And that will be our R triple prime, S triple prime, T triple prime. And remember, anytime it says state the coordinates, we have to write them down. All right, I will see you in class.